This video in the Resources on Proof series is about how to prove that something is a subspace of a vector space. So let's look at an example question, a typical situation where you might be asked to prove that something is a subspace. Here we have, for each of the following, determine if it is a subspace of R3 over the field R. So we have S1, which is the set where the first coordinate can be anything, the second coordinate can be anything, and the third coordinate must be 0. In S2, all three coordinates have to be the same, but they have to be the same rational number. And in S3, we're looking at the union of two sets, one where everything's 0 apart from the first coordinate, and the other one, everything's 0 apart from the second coordinate. So the first thing to do when presented with any kind of question is to recall the definitions involved. So let's bring up the definition for a subspace. Here's the definition. If V is a vector space and S is a subset of V, we say that S is a subspace if and only if it satisfies both of these conditions. The first condition says that if we take any two vectors in S, we add them together, we end up with something still in S. And the second one is if we take any element of S and multiply it by any field element, we still stay in S. So let's apply that definition to the question to get our proofs. So let's first look at S1. This is the situation where the first and second coordinate can be anything, but the third coordinate must be 0. So we're going to look at condition 1, and we're going to do a direct proof. So let U and V be arbitrary elements of S1. Then we add them together, and through some calculation, we see that we end up with something that's also in S1. So S1 satisfies condition 1. Now let's look at condition 2. Again, a direct proof. We take an arbitrary element of S1, an arbitrary real number, which is our field element in this case, multiply them together, a bit of calculation, and we end up with something still in S1. Because S1 satisfies both conditions, it's a subspace of R3. Let's look at a second example. S2, all three coordinates must be the same rational number. So let's look at condition 1. If we take two arbitrary elements of S2, add them together, we end up with something still in S2. So this satisfies condition 1. Let's look at condition 2. Now, because condition 2 is false here, I'm going to go for a counterexample. Rather than a proof about why it's not true, I'm just going to give a single counterexample that says that this condition is false. So I'm going to let U be the vector 1, 1, 1. I'm going to multiply it by root 2 and end up with something that is not in S2. And since S2 doesn't satisfy both of the conditions, it fails condition 2, it is not a subspace of R to the 3 over R. Let's look at S3. This is the union of two sets. First one, where everything but the first coordinate is 0, and the second one, where everything but the second coordinate is 0. We take their union. Let's look at the first condition. Now this is false, so again, I just need a counterexample rather than an elaborate proof. So let U be 1, 0, 0, let V be 0, 1, 0. I add them together, and I've left the union. So S3 fails condition 1. And because S3 has failed condition 1, there's absolutely no need to consider condition 2. Something is a subspace if and only if it satisfies both conditions. So since it's failed condition 1, I don't need to think about condition 2. I know it's not a subspace. There's a written version of this resource available. Thank you for watching.